Vocabulary of polynomials. You can do math, but can you speak it? And can I write it? Here are some important definitions related to algebra. A formula is a general rule for calculating something. And we know that, right? It's one of the secrets to math. Formula is substitution and answer. Give some examples of formulae, fancy plural of formula, that you know. Well, how about C is equal to 2 pi r. I is equal to P r t. E is equal to mc squared. That's some formulas, and I'm sure you know plenty of others. I know you do, because you know all of the area and volume formulas, so that's lots. Variable, letters representing different values. Take one of the formulae from question 1 and identify the variables. So let's take C equals 2 pi r. There are two variables. There is C, which is the circumference, the distance around a circle. 2, not a variable, that's a number. Pi, not a variable, that's also a number, although it's irrational. And there is r, which is the radius of said circle, whose circumference we will get by plugging into this formula. Algebraic expression, an expression which involves variables. So w squared plus w is an algebraic expression. 3 plus 2 times 7 is not. That's an arithmetic expression. It's arithmetic if you can evaluate it, right? 14 plus 3 is 17. True or false? A formula always involves an algebraic expression. True. Right? Because otherwise it would be an arithmetic expression, and then it's not a formula, it's just something we would be evaluating. If values are substituted into a formula, then it becomes an arithmetic expression. Also true, because then we can evaluate it and find out what the answer is. Coefficients. A coefficient is a number that is multiplied with a variable. For example, the height in meters of a ball thrown in the air is given by 80t minus 5t squared, where t is the time in seconds. In this expression, the coefficients are 80 and negative 5. List the coefficients in each of the following in their respective order. So the first coefficient is 3. Then, okay, now we've got to be careful and make sure we get the negative with this. Negative 5, and then 2. Negative 14. Now, does b have a coefficient? There's no number there. Well, yeah, there is. It's 1b. So we need to put down the 1. And negative c is negative 1c. So we have negative 14, 1, and negative 1. Monomial, a number or the product of a number with one or more variables where the exponents on the variables are whole numbers, such as 0, 1, 2, 3. Examples. Negative 15 is a monomial. Monomial simply means one term. 250. So any number is a monomial. 3x, a number with a variable. Negative 7, a squared. This is the coefficient. 18, p cubed, q to the 5th. Again, coefficient 1/2. That's fine, right? It's these guys can't be fractions. N to the negative 3. That is a negative exponent. And the exponent has to be a whole number. Negative 8, p to the 1/2. Well, that's negative 8 square root p. That's too radical. 17r squared. That's 17r to the negative 2. So the exponent is not a whole number. It is an integer. And that's why these are not monomials. If an expression is in its simplest form and a variable appears in the denominator, this could also be written 1 over n cubed. So a variable appears in the denominator, or here it is in the denominator, or under a radical sign. The fractional exponent does that. Then the expression is not a monomial. So make sure you can identify monomials from not monomials. Polynomial, a monomial, or the sum of two or more monomials. And by sum, we mean add or subtract, sum or difference, because a minus is really just plus a negative. 5x squared, monomial. Perfectly good. 1/2 AB, monomial. It's the exponents that can't be rational, not the leading term. The coefficient can be. 100 plus 60t minus 5t cubed, polynomial. 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 Terms. How many terms? Terms are things which are separated by a plus or a minus sign. So one term. Also called a monomial. Two terms, right? There's the plus sign. Two terms is called a binomial. Three terms called a trinomial. Okay, again, terms are monomials. That's a monomial, separated by a plus or a minus sign. A polynomial with 4 or more terms has no special name. 8a minus 2b plus 5c minus 3 is called a polynomial of 4 terms. Okay, let's go look through these and indicate if they are monomials. 3a squared times 3a squared. That is a monomial. It's a little bit weird in a sense. We really probably should just write this as 9a to the 4th and call it a monomial. Negative m plus pq squared, 2 terms, binomial. 2a cubed plus b, binomial. Okay, remember the mono, bi, tri refer to the number of terms, trinomial. Monomial. Doesn't matter how many letters we have, and 1, 2, 3, 4. This is a polynomial in 4 terms. Polynomial. And if we want to be more specific, then we say in 4 terms. Constant term, a term in a polynomial that is only a number. That is a term that has no variable. So for the expression 2x squared minus 7x plus 3, the 3 is the constant term, right? No variable. Constant term has no variable. State, which means just write it. So -6, this is negative. +12, we don't write the plus sign if it's positive. And there isn't one here, right? So this is 0, right? You could write a +0 if you liked. The degree of a monomial, the sum of the exponents of the variables. Okay, so we have variables. Variables have exponents. If they're not shown, it's a 1. That's a to the 1, which I've now turned into a d. Okay, so that's a to the power 1. Write that up there. So the degree of this is 1 plus 2 plus 3, degree 6. Since the monomial 17 has no variable, we say the degree of 17 is 0. This is degree 0. Determine the degree of each monomial shown below. Technically, I guess you could say determine, show the work. Well, this is degree 1. This is 1 plus 1, which is 2. So I guess here, determine 1 plus 1 is 2. This is degree 0. This is degree 2. It's just got a 2. There is no variable. And this is degree of 3 plus 5. So it's degree 8. So 8, 2, 0. Whoops, a little carried away there. Degree 2, degree 1. That's for a monomial. So each monomial has its own degree. A polynomial is the degree of the term of the highest degree. So we're going to have different terms, right? Different monomials. Different monomials. Each of which has a degree. This is term of degree 3, degree 2, degree 1, degree 0. And we want the degree of the term of highest degree, so it'll be degree 3. So this polynomial is of degree 3. Polynomials are normally written in order of descending degree. The term with the highest degree is written first, and the term with the lowest degree is written last. When 7x minus 2x cubed minus 10 plus x squared is written in descending order, you start with the negative 2x cubed plus x squared plus 7x. Notice no leading negative, so it's plus 7x minus 10. For each polynomial, determine its degree. Okay, degree 0, degree 2, degree 3, degree 1. It's of degree 3. And express it in descending order of degree. So we're going to start with 2a squared b. Go to degree 2, minus 7ab. Degree 1, minus b. And then plus 4, the degree 0 term. This polynomial, degree 1, degree 3, degree 0, so it's of degree 3. We write negative t cubed plus 14t. See, this will be a plus, minus sign, and then minus 2. Name, we can name these by degree. So degree 1 is called linear, degree 2 quadratic, degree 3 cubic, degree 4 quartic, degree 5 quintic, degree 6, degree 6, degree 7, degree 7, and so on. If we go above 5, and oftentimes even these we'll just say of degree 4 or degree 5, but we will always say linear, quadratic, or cubic. Once we get above that, though, we might use the fancy names or not. And speaking of fancy names, this is over what's up next. We have common factoring. So up until now, we've learned to write numbers as a product of their factors. But what about an algebraic expression? So write 20 in as many factored forms as possible. Okay, so I can go 1 times 20, 2 times 10, 3 doesn't go in, 4 times 5, 5 times 4. This is really just going to repeat. 10 times 2, 20 times 1. Now I ask, do any of these factor? Well, 4 can be 2 times 2, so I can write 2 times 2 times 5. 10 is 5 times 2. Really going to be the same. I mean, I guess we could write this 3 times, we go 2 times 5 times 2, and we could go 5 times 2 times 2. Really, I would just treat these as one way, and I normally wouldn't write these unless we were specifically talking about making a rectangle with a length of 1 and a width of 20 to be different from a length of 20 and a width of 1. Factoring algebraic expressions. Okay, here we go. Factoring, the most important skill you will have learned in math up to this point in time. An example of an algebraic expression is 3x minus 6. Since x is a variable in the expression 3x minus 6, this means the value of x can change. So let's evaluate 3x minus 6 when x equals 8. 3x minus 6 will be 3. We're going to replace the x with an 8 minus 6, which is 24 minus 6, which is 18. How about when x is 15? So 3x minus 6 is equal to 3 times 15 minus 6, which is 45 minus 6, or 39. Write 3x minus 6 as a product of two factors. Well, I notice that 3 can be divided into both 3x and into 6, leaving me with 3 times x minus 2. So there's two factors. Substitute x equals 8 into the factored form. So I've got 3 times 8 minus 2, which is 3 times 6. Substitute 15 in, so I have 3 times 15 minus 2, which is 3 times 13. Now you notice 18 is 3 times 6. 39 is 3 times 13. So the answers in part C are simply a factored form of the values from part A. So are they? You betcha, Red Ryder. As you can see, the factored form of the algebraic expression will give us a factored form of a number when a value is substituted in for the variable. I kind of read that sentence with not good emphasis. Express 18a minus 36b as a product in as many ways as possible. So I'm going to start off by saying, hey, look, they're both even, so let's divide them both by 2. So I divide each term by 2. Now notice you multiply this out, you get 18a minus 36b. That's always a check for a factorization is, will it expand out? In this case, using the distributive law to the original. Okay, does 3? Yeah, 3 goes into 18 and 36. 6a minus 12b. So I divide each of these terms by 3. How about 4? No, goes into 36, but not 18. 5? Neither. 6? Yes. 18 divided by 6 is 3. So I need to get 18, a. And 36 divided by 6 is 6, so minus 6, b. 7, no. 8, no. 9, yes. 9. 18a divided by 9 is 2a, right? I often just think, what do I need to multiply 9 by to get 18a? What do I multiply 9 by to get 36? And then I need the b. 10, no. 11, no. 12, yes, no. 13, no. 14, etc., up till 18, which is a minus 2b. Each of these multiplied out using the distributive law will give you 18a minus 36b. And I don't think I can do anything further. Which of the expressions would be one that is factored completely? So if we look here, we say, hey look, I can still divide both of these guys by 9. I can divide both of these by 6. I can divide both of these by 3, both of these by 2, but that is as far as it goes. There's nothing that goes in other than 1. There's nothing that goes into both 1 and 2. So the expression that's in fully factored form, which simply means you can no longer factor, right? There's nothing left in either term that can be divided out. So 18. Explain why there is nothing left that can be factored. And that's what we mean by factored fully. And as a matter of fact, whenever you see the word factor, this is what it means. It means factored completely. Whether we say it or not, when you see factor, it must be factored completely. Very important point. Number 3, state the prime factorization of 20. Well, we can split this up. It doesn't hurt to factor down a tree. So the prime factorization of 20 is 2 times 2 times 5. With prime factorization of numbers, we stop when we have an individual factor as a prime number. Prime, prime, prime. Prime, prime, prime. Not prime must factor into product of primes. With an algebraic expression, it's said to be completely factored if each individual factor cannot be factored further, right? The 10 here can be factored further, we have to do it. With an algebraic expression, it's completely factored if we can't factor further. And let's go back and down. This can be factored further. I can take in this can be factored further, right? There's something in common. If we can factor further, we are not completely factored. The first step to factoring an algebraic expression is to look for the greatest common factor of all the individual terms. That is all we will look at today. But as the unit progresses, we will look at other expressions that can also be factored. It's funny, I read it awkwardly the first time I read it. Okay, let's finish this off. So we're going to factor completely. Remember to check your factors to see if they can be factored further. So here we go, non-factored. The greatest common factor. What is the biggest number that goes into 16, 24, and 4? And that number is 4. The factored form. We then write the GCF, and then we write down each of these terms divided by 4. So 16 divided by 4 is 4a. Now notice there's no common letter. So that's not part of the greatest common factor. All we have is numbers. Notice there are 3 terms. which means we need 3 terms in the bracket so that they will expand back out. 24 divided by 4 is 6, and 4 divided by 4 is 1. If we expand this out, 16a plus 24b minus 4c, nothing common in here. They don't all have an a. The greatest number, or the smallest number that's left, is a 1, so we can't divide these out further. We can't say, hey, 2 goes into these guys, because it's not common. It would have to go into this as well. Greatest common factor, in this case, just variables. The largest variable that goes into both is x cubed. So I put my greatest common factor down, and I say, how do you get x to the 5th? Well, 2 plus 3 is 5, or 5 minus 3 is 2, minus, now I need an x cubed, and I'm going to multiply. What do I multiply by x cubed to get x cubed? 1. Nothing common in here. Okay, so at the moment we're done. This actually does factor further. We just don't know how yet, and we're not going to do it. We're just doing greatest common factor. What's the biggest number that goes into 30 and 12? Okay, I think that's 6. But let's say that I said it was 3. Here, let's make a mistake. 3, and we'll say p to the 4th. So I write down my greatest common factor. Don't do this. I'm doing this on purpose. So 3 times 10 gives me 30, and then p to the 4th. So I just need the 10. This will multiply to 30 p to the 4th, minus, to get a 12. 12 divided by 3 is 4. To get a p to the 7th, I've already got a p to the 4th. 7 minus 4 is 3. Now, hey, there's a problem. 10 and 4 are both divisible by 2. Which means we erase. Which is why you use pencil. And we erase because we missed. We should have said 6. That's the largest number that goes into 30 and 12. So 6p to the 4th, 30, right. Yeah, let's put a 3 down. That's really good. 6 times what gives you 30? 6 times 5. This times this will give you 30p to the 4th. Okay, got that. Minus, how do you get a 12? 12 divided by 6 is 2. I need a p to the 7th. 7 minus 4 is 3, so that's a p cubed. Right, you multiply this back out. Every time you factor, you check. Check 2 things. Number 1, is there anything in here? Are these both divisible by the same thing? Do they each have a p? No. 5 and 2? No, they're not. They're both prime. Okay, 30p to the 4th minus 12p add 7. Yes. 2 terms here. Largest number that goes into 30 and 6 is 6. They both have a's. We go with the smaller a. So a to the 4th. They both have b's. We go with the smaller power of b because it'll go into both of them. B to the 6th won't go into b squared. This has a c, this doesn't. Okay, so there's no c here. 6, a to the 4th, b squared. I want to get 30. 6 times 5 is 30. I want to get a to the 10th. 10 minus 4 is 6. A to the 6th. I want to get b squared. I've got b squared. I want to get a c. Okay, I'm going to need a c. Okay, this times this must give me this. Now we got a minus sign. Okay, I want a 6. You don't need a number. Need a to the 4th. Got an a to the 4th. Need a b to the 6th. I've only got b squared. Let's put down b to the 4th. So this will give me 6, a to the 4th, b add to the 6th. Okay, if there are 2 terms here, then there must be 2 terms in the brackets. 3 terms here must be 3 terms. 2 terms must be 2 terms in the bracket with the greatest common factor out front. I need 5xa, 5x minus 3a minus 3. The a is there, 5xa minus 3a. Common, now this is weird, right? This is different. In this case, it's y minus 2 is the common factor. So we write out y minus 2. How do we get 5x times y minus 2? We put a 5x. Okay, that takes care of this first term, which I do not want to do. How do we get minus 3 times y minus 2? We put down a minus, give me back. We put down a minus 2. So you multiply y minus 2, or 5x times y minus 2, minus, what are you doing? That's a 3. I know you knew. Just checking. And then minus 3 times y minus 2. Same deal, binomial common factor, 2n minus 5. You're going to see this from now on. What's left? 4m plus 7. Okay, so the common factor may be a number. It may be a number with letters. So it might just be a number. Might just be a variable. Might be a combination of a coefficient, right, number in front, with the variable. Maybe a binomial. This is a binomial common factor, right? It's common to this and to this. When we factor it out, what are we left with? You know, it's gone, and we're left with 4m plus 7. That's where that comes from. Same with the y minus 2's, right? When it's factored out, we're left with 5x minus 3. That's where that stuff comes from. And I'm just going to clean it back up to its pristine original condition. There, it's mint. Okay, now it's mint. To factor an expression by common factoring. Common factoring is the first step in any factoring. Anytime you factor, you are going to do common factoring first. At least you're going to see if it does. So how do you do it? You find the greatest common factor, that is the largest expression that divides into all of the terms. You write down the GCF and you open a set of brackets. If the GCF has more than one term, make sure to put it in brackets. These binomials here must be in brackets. You divide each term by the greatest common factor and write the answer in brackets, keeping in mind that however many terms were in the original, that's how many terms you're going to have in your brackets. You check your answer by multiplying. If the original expression is not in a simplified form, like this one, this is not simplified, the way to check is to multiply both the original expression and your answer to see if they are equal. Okay, so you would multiply this out and this and see if they were equal. Okay, and we will save that for a little bit later because we have to learn how to multiply binomials first. And we're done.